This video is going to look at some examples involving our inverse trig functions. And the first one that I want to look at here is if we have the inverse sine of a negative square root of 2 over 2. What does this equal? Well, remember the inverse sine, I always like to refresh your memory and even mentally think of this, or you may even actually want to sketch this out. The inverse sine, if you recall, we said that the angle has to be somewhere from a negative pi over 2 up to a positive pi over 2. So that's going to be the range or the only possible outputs that we can have for the inverse sine function. So that means we're going to look here in the first quadrant, or what I like to call the negative fourth quadrant, for an angle where the y value, because remember sine is our y, so where do we have a y value that's a negative square root of 2 over 2? Well, because it's negative, that means we're going to be going down on the y, so it's got to be in this fourth quadrant. So what angle in the fourth quadrant do we have a negative square root of 2 over 2? And that's going to occur right here at a negative pi over 4. So therefore the answer is a negative pi over 4. Now keep in mind, I know if you look at the unit circle, the positive angle would be equal to 7 pi over 4, but realize 7 pi over 4 is not one of our possible answers within this range. Okay, next example is the arc sine of a negative 1/2. Now I'm using this notation, but realize this notation here, the inverse sine and this arc sine is the same thing. So this is still the inverse sine or the arc sine of a negative 1/2. And once again, because this is our sine function, the angle has to be somewhere from a negative pi over 2 to a positive pi over 2. And again, the arc sine, we're looking at the y value. So where do we have a y value that's a negative 1/2? Well, if we look at a negative 1/2, again, it's negative, so we have to be going down. So it's got to be in the fourth quadrant. Otherwise, if it's in the first quadrant, your y value is going to be positive. So where do we have a y coordinate that's a negative 1/2 in the fourth quadrant? And if you look, that's going to occur right about here, and that means we're going to have an angle that is a negative pi over 6. Okay, because if you look at the coordinate there, and again, the negative pi over 6 would be the same location as 11 pi over 6, and the actual coordinates here, you would see you'd have an x coordinate of square root of 3 over 2, and your y value is equal to the negative 1/2. So that's what we're looking for here. We have a negative 1/2 that occurs at this negative pi over 6. So once again, when we're using these inverse trig functions, keep in mind here that the answer that we're going to get out is going to be the angle that we're looking for. All right, so let's look at the third example. And this one here, we're going to look at the inverse cosine of a negative square root of 3 over 2. And this one's going to be a little different because remember the inverse cosine, our possible answers are going to go from 0 over to 1 pi. So that means your answer has to be in the first quadrant or the second quadrant. Now we know that cosine is our x value, and if it's negative, that means we would have to be in the second quadrant. So where in the second quadrant do we have an x value of a negative square root of 3 over 2? Well, if you go to your unit circle, we can see that you're going to have an x value of a negative square root of 3 over 2 is going to occur at 5 pi over 6. So we have an angle of 5 pi over 6. And again, if you look here, the actual coordinate at 5 pi over 6 would be a negative square root of 3 over 2 and a positive 1/2. So once again, here's our x value of a negative square root of 3 over 2, and our angle at that point is 5 pi over 6. Okay? All right, so there's an example of the inverse cosine. So now let's look at a fourth example, and this one we'll look at the inverse tangent, and we'll look at the square root of 3. Now keep in mind the possible answers for the inverse tangent. The inverse tangent is similar to the possibility for the inverse sine. It's going to go from negative pi over 2 to pi over 2, but instead of having filled in a dot here, we're going to have open circles. So we can go from negative pi over 2 to a positive pi over 2, but the endpoints are not included, and that's why we have an open circle. So basically that means you would never have an answer here of pi over 2 or negative pi over 2, only angles that are in between. So once again, we're looking at the first quadrant or the fourth quadrant, but if we're in the fourth quadrant, we know we're looking at the negative angle. Well, our tangent here, inverse tangent, we're looking at the square root of 3. Well, that means where do we have a y-coordinate divided by the x-coordinate to equal the square root of 3? Well, because it's positive, we know that we're going to be in the first quadrant. So we need to find an angle in which the x and y coordinate, if you take y divided by x, you're going to get the square root of 3. So I'm going to look at, well, we have two possibilities. We have here pi over 6, and then up here we have pi over 3, because we know in the middle pi over 4, that's going to have the same x and y value, so that's going to be equal to 1. So at pi over 6, we have this point, the coordinates are square root of 3 over 2, 1/2, and then at pi over 3, the coordinates are just the reverse, 1/2 and square root of 3 over 2. Okay, so we want to know which one is going to give us the square root of 3. Well, this one already has, we have a y value, and here's our x and our y. And I'm going to maybe guess the first one here. If we take this at pi over 3, if we take our y coordinate, that means we're going to take the square root of 3 over 2, and if we divide this by 1/2, well, that means we're going to multiply by the reciprocal. So the reciprocal of a half would be 2 over 1. So if we multiply by 2 over 1, the 2's are going to cancel out, and we certainly are left with the square root of 3. So that tells us if we take y divided by x, we get the square root of 3 that we're looking for. So therefore, the angle we want to use, or it's going to be equal to, is pi over 3. All right, now I want to look at, this is how we could find the inverse function using the unit circle, but now we want to look at how can we use our calculator. And of course, this is going to be very simple to do. And the first one I'm going to look at is the very first example we did up here. So I'm going to look at the inverse sine of negative square root of 2 over 2. So if I take the inverse sine of a negative square root of 2 over 2, then we can go to the calculator. Now, a lot of times the question becomes, what mode do we want to be in, degrees or radians? Well, most of the time here we're dealing with radians. So I'm going to make sure our mode is in radians, so, which it is. So if I go here and type in now second function sine, I would type in negative square root of 2 divided by 2, close the parentheses, and you simply hit enter. And we get a negative 0.78, or we'll round it to a negative 0.79. Okay, and that's all there is to it. Now, this answer is in radians. And how do I know it's in radians? It's because our calculator was in radian mode. And if we go up here, excuse me, we had a negative pi over 4 for the answer when we use the unit circle. Well, if I go to the calculator and I type in negative pi divided by 4, we're going to get the exact same answer. So that kind of checks that we did it correctly using the unit circle as well as the calculator. So for example, I do want to point this out. If we took the same problem, inverse sine negative square root of 2 over 2, and if we have the calculator here in degrees, let me clear this out. If we go into, let's see, second sine negative square root of 2 divided by 2. Now I want to go into the mode, and I'm going to change this to degrees. Now again, I think for all our problems we're going to be in radians, but if I change this into degrees, and now we have this inverse sine of negative square root of 2 over 2, and I hit enter, we get an answer of a negative 45. And that's because here we are now in degrees, so this is equal to a negative 45 degrees. And we know that if we were looking at our circle, that this is a negative 45 degrees, or this is equal to pi over 4, which is approximately equal to the decimal of a negative 0.79. So whatever mode that your calculator is in is the angle that you're going to end up with. And I believe for a lot of our examples, we're going to be in radians. So before I forget, I'm going to go back and change my calculator back into radian mode. Okay. So be very careful with what mode your calculator is in. So let's look at another example here. Let's say that we have the arc cosine of a negative 0.7. Now, of course, this is one that we could not use the unit circle because we just have a decimal here. We can't find this, so we would certainly have to use our calculator. So we would go, and again, this is arc cosine. This is the same thing if I was to write this inverse cosine. So on the calculator, we're going to go second cosine of a negative 0.7, close the parentheses, hit enter, and we get 2.35. So this is approximately equal to 2.35. And again, we know that's in radians because the calculator was in radian mode. Okay, so hopefully now you feel comfortable with evaluating or finding these values using your inverse trig functions.